Hi everyone, we're going to start differentiation, and it's a big topic. There's lots to sort of explore and learn, so we'll take it step by step. This is the first lesson, and what I'm going to do is go over the algebra of differentiation. Later on we'll look at what this exactly means and how it's used, so about 3 stages. The algebra of differentiation works like this. Say I've got y equals 3x squared, so you've got an equation like that, and you want to differentiate this. What you'll do is you'll write down dy over dx. Okay, so you write dy over dx, that means you're going to differentiate the y, and the rule is let's write the 3x squared over here, and this is what happens to it. We bring the power down, okay, and take 1 away from the power. So this becomes, the 2 comes down, so you get 2 times 3, which is 6, okay, and then you take 1 away from the power, so you get 1. So now this is now differentiated. Okay, and what this means in terms of y we'll look at in due course. So let me give you 1 or 2 to do. You can pause the video, practice it, and then check if it's correct. So let's do y equals 4x cubed, and let's do another one, y equals 3x squared plus 2x. Okay, you might want to pause the video and have a go. Right, so the solution to this is, we'll write down dy over dx equals, the power comes down, so we get 3 times 4x, you take 1 away from the power. So I'm writing all my working out here, because this is probably a method mark that I'll pick up in the exam. And we've got 12x squared. Okay. Similarly here, we've got dy over dx equals 6x plus 2. Okay, so the power comes down, and then we take 1 away from the power. So the 2 times 3, okay, the 2 times 3 over here gives us the 6. Now with, and then we take 1 away from the power, so 2 becomes 1. Now with this one over here, this x is to the power 1. So when we take 1 away from the power, what essentially we've got is x to the power 0, which is just 1 anyway. Okay, let's look at another example. Okay, so let's look at this example here. This time we've got 3 terms. You might want to pause this video and have a go at this. Right, so this is what we've got. We're going to differentiate this. We've got dy over dx, and then I'm going to write all my working out to pick up the method mark. So you've got 3 times 2 x, and then 3 take away 1, take away 5 times 2 times x, 2 take away 1, and then that 4 just becomes a 0. So if there's nothing next to it, that coefficient over here, because we're differentiating with respect to x, there is no x here, so it doesn't pick anything up. It doesn't do anything to that. That just disappears. And what we get is 6x squared take away 10x to the power of 1. Okay. Right, let's move on to another example. Okay, so let's look at this example here. They want us to find the derivative of y, and then find the gradient. So let's do the first part first, and then we'll come on to the second part. Now, to find the derivative of this, what we'll need to do is expand this term out. So we've got y equals x minus 2, x squared plus 1, and that will give us x cubed plus x minus 2x squared take away 2. So that gives us x cubed minus 2x squared plus x take away 2. Okay, now we can differentiate. So let's write down dy over dx equals, the power comes down, so we've got 3x, 3 take away 1, okay, minus 2 times 2, x take away 2 take away 1, plus 1. So this becomes 3x squared take away 4x plus 1. So that's the derivative. Now it asks us to find the gradient of the curve at a certain point. Now this is what's going on. When we differentiate this dy over dx, this is the gradient of y. So if you look carefully, here's a cubic, and over here we've got quadratic. So this quadratic is a gradient of this cubic, and later on in class or later on we'll have a look at this in more detail. So we've been given a point. We know x equals 2. So if we substitute the x equals 2 in here, we will know the gradient at that point, x equals 2. So let's do that. So we can put down 3 times 2 squared take away 4 times 2 plus 1. So 2 times 2 is 4, 4 times 3 is 12, take away 8 plus 1. 12 take away 8 is 4, add 1, we get a 5. So this is the gradient, okay, of the curve y at that particular point, 2, 0. Now, needless to say, if I substitute other values of x in, I'll get a different value of the gradient. Okay, let's have a go at this question here. Now again, to differentiate this, what we need to do is put it in standard index form. So let's write down y equals 3x squared take away 2x take away 4x over 4 divided by 2x. So the x's cancel, so we get 3 over 2 x, 2 take away 1 is just 1, 4 over 2 is x, and then we get x cubed. So now it's in standard index form. We can now differentiate, so we'll write down dy over dx equals, and then for the first one, so we've got 3 over 2 times 1 times x to the power, take 1 away from the power, so 1 take away 1, minus 2 times 3 x to the power of 3 take away 1. So this gives us 3 over 2 take away 6x squared. Okay, so here's a little question I'd like you to do. We'd like to do this. So here's y, find dy over dx, and well, it's already given to you. What I'd like to do is work out what this power is and enter it on the form attached to this video clip. Okay, so here's a question where we've got to sketch the gradient function of this curve, the gradient function is obviously dy over dx. So what you basically do is work out the gradient at each point, and then you sketch it. Now there's a few key points that we should automatically note, and I'll put this in, say, red. It's the point where dy over dx equals 0. So you've got one point there, you've got another point there, and another point there. And if we were to draw the line straight down, they will correspond to the points where the graph cuts the y-axis. Again, dy over dx is represented by the y-axis, and that's where it's 0. What you then want to do is look at where the gradient is positive, okay, and then it gradually increases and then decreases, and then here it's negative, here again we've got negative, and then over here it's a positive. So the corresponding regions, therefore all that positive region here will correspond to, all this positive region correspond to this positive region here, and this negative region obviously here, this positive region goes up, and then we have a negative region which is below the x-axis over here. So those are some key points. The other thing to bear in mind is what you've got here is a cubic, and what you've got here is an equation where the highest power is a 4. Okay, let's look at this question here. So it says find the equation of the tangent to the curve y equals 2x cubed minus 3x at the point with x coordinate 1. So firstly we need to know, to find the equation of the tangent, let's just write this down. So equation of a tangent, which is a straight line, is y minus y1 equals mx x minus x1. So it turns out we need three things. We need to know what x1 is, what y1 is, what m1 is. Now we know the x coordinate is 1, we know that. We need to work out what m and y are going to be. Now y we can work out just by substituting the x back in. So you've got a cube there, take away 3 times 1, so that just gives us minus 1. And now we need to work out the gradient m. The gradient is given by differentiating. So we do dy over dx equals 2 times 3, which is 6x squared, take away 3. Okay, and if we then substitute x equals 1, because it's the gradient at that point when x equals 1, then we have 6 times 1 squared take away 3, which is 6 take away 3, which equals 3. We put that in there. So y take away minus 1 equals 3x minus x1 is just 1. So that gives us 3x take away 3 plus 1, just be careful of the signs there. So y equals 3x take away 3 take away 1. I'm showing all my working out to pick up all the method marks. And then we've got y equals 3x take away 4. So that's the equation of the tangent at that point. Okay, so we've got an example where we've got to show that the normal to the curve at the point 1 minus 1 passes through the origin. Now, what do they mean by this word normal? Well, we know if you have a tangent, okay, let's call that a tangent, then the normal is 90 degrees to the tangent. So what we need to do is work out the gradient of the tangent, and then that will give us the gradient of the normal. Right, so let's begin. We want to work out dy of dx. So dy over dx, which is the gradient of y, is the power comes down, so you got, and then we take 1 away from the power, and then we've got 3x to the power 0, and this equals 4x take away 3. Now at the point when we have x equals 1, okay, we can work out the gradient by substituting x equals 1. So we've got 4 times 1 take away 3, which equals 1. Therefore we can conclude that the gradient of the normal, of the tangent, sorry, let's call it mt equals 1. Now we know that the gradient of the normal times the gradient of the tangent equals minus 1. Therefore the gradient of the normal equals minus 1 over 1, which equals minus 1. We can now substitute the x and y values over here to form an equation for the normal. So we've got y minus y1 equals mx minus x1. And if we substitute x equals 1, so the gradient is minus 1, x minus 1 equals y minus 1. So it leads to y plus 1 equals minus x plus 1. So y equals minus x plus 1 take away 1, which is just 0. Now, we know this line passes through the origin because it just goes straight through. We can test it. So at x equals 0, y equals 0. Therefore, y equals minus x passes through the origin. Okay, so let's look at this question here. We've got the curve has equation y equals x cubed minus x squared plus x plus 2, and the x coordinate of the points on the curve we want to find the x coordinate points on the curve with gradient 6, and then the x coordinate of the points on the curve with gradient minus a half. So Let's begin with the first one. We've been told the gradient is 6, so this means dy over dx, the gradient, equals 6. And so this equals 3x squared take away 2x plus 1. Okay, and we know that equals 6. If we rearrange this, we get a quadratic. We've got 3x squared take away 2x take away 5 equals 0. You might want to pause the video here and solve that quadratic. You should get, by factorizing, x equals 5 over 3, or x equals minus 1. Now, with the second equation, we've been told that the gradient of the normal is minus a half. If the gradient of the normal is minus a half, then the gradient of the tangent equals 2. And we know that because the gradient of the normal times the gradient of the tangent equals minus 1. And therefore, the gradient of the tangent equals minus 1 over minus a half, which equals 2. And so, if we substitute that in, we get 3x squared take away 2x plus 1 equals to 2. Again, if we rearrange that, we get 3x squared take away 2x take away 1 equals 0. If you want to factorize that and solve it, you should get x equals minus 1 over 3, or x equals 1.